This is Nitya, Assistant Professor, Department of Mathematics from St. Anne's Arts and Science College. Today we are going to see the numerical methods, Newton's backward interpolation. So in that Newton's backward interpolation, we are having one formula, that is f of a minus nh equal to f of a minus n into del f of a plus n into n minus 1 by 2 factorial into del squared f of a minus n into n minus 1 n minus 2 divided by 3 factorial into del cube f of a plus and so on. So this is the Newton's backward interpolation formula. Using this formula, we are going to solve the problem. So already I have told you that Newton's backward, that is a backward means the which value we are going to find, that should be the end of the data. That value should be the end of the data. So if it is the beginning of the data, we should use a Newton's forward interpolation formula. Since we are going to use the backward for, it should be the end of the data. The data which the value which we are going to find, it should be contained in the end of the data. So it is called as the Newton's backward interpolation. So the population of a town in a population census were under S. Estimate the population for the year 1955. So they are asking 1955. For that, what is the population in thousands they are asking. See that year 1921, 1931, 1941, 1951, 1961. Population is in thousands as given as 46, 66, 81, 93 and 101. So from this we are going to find for the population of the year 1955. See here, this is 1951 and 1961. It is in between. The 1955 is in between. That is the end of the document, end of the data. So we are going to find the value for that 1955. So we can move for the solution. Since we have to find, that is already what I have said. We have to find the population for the year 1955, which is towards the end of the table. So we have to apply the Newton's backward. So let A minus NH equal to 1955. So this is what value we are going to find. So take it as A minus NH. A equal to 1961, that is the last X value. Because on the previous problem we have taken that it's a forward, so we have taken the first X value. But here it is a backward, so we are taking the last X value. And H is a difference as usual, it is a difference in X. So H is equal to 10. So A is 1961 minus 10 and N equal to 1955. So 1961 minus 1955 equal to 10N. So 1961 minus 1955 is 6, which is equal to 10N. So N equal to 6 by 10, which is equal to 0.6. So N value we had find. Now we can write the backward difference table. So how will you write the backward? As usual, we have to write the backward difference table. Only the del is different here. So x, y, del square, del cube, del power 4. So write the x values and y values. As usual, del is 66 minus 46 is 20. Then 81 minus 66 is 15. 93 minus 81 is 12. 101 minus 93 is 8. Now again we have to subtract. 15 minus 20 is minus 5. 12 minus 15 is minus 3. 8 minus 12 is minus 4. Minus 3 minus 5 is 2. Minus 4 minus 3 is minus 1. Minus 1 minus 2 is minus 1. Minus 2 is minus 3. So now we should take only the lower values, that is which we have taken the 8, minus 4, minus 1, minus 3 only we should take. Because it's a forward difference interpolation, so we have to take the lowest value. See that I have highlighted here. So take that value. Now we have to substitute in the formula. F of a minus nh equal to f of a minus n into del f of a plus n into n minus 1 by 2 factorial into del squared f of a minus n into n minus 1 n minus 2 divided by 3 factorial into del cube f of a plus n into n minus 1 n minus 2 n minus 3 by 4 factorial into del power 4 f of a. Therefore f of a equal to 101. That is the last value. And then apply that remaining values. Del f of a is 8, del squared f of a is minus 4, del squared f of a is minus 1, del power 4 f of a is minus 3. So substitute all the values here, and then you just simplify that each term. After that you can do the addition or subtraction and get the answer as 96.523. So the population of the year 1955 is 96.523 thousands. Thank you girls. Hope you understand. Thanks for watching.